What can Visinode do with a visual sensor? Join us to find out. For starters, we will create a general-purpose watchdog and move on from there. In the following, we will attempt to create an application using a few pre-written Visinodes. The first Visinode dragged into visifront is a short movie containing a spinning color calibration system, constructed and recorded using Visinode running locally under Linux. The video color sensor may be dropped into any element. It operates only if it finds itself over a video. This Visinode uses by default the built-in printing facility, vprint, of visifront to report its discoveries. Please note how the vprint reading changes as the color sensor is dragged over each color. When the video color sensor is dropped into a Visinode that has no video element, it naturally stops reporting. Visifront has been set to prioritize coding, so with a right-click on a Visinode, the Edit Script option comes first. This option pops up a rudimentary coding window, meant to be used to modify the code element of Visinodes. The video sensor code is about as formidable as the Visinode code will get. Please don't be discouraged, most Visinodes are much simpler. The next step for our application is to create a visual display panel for the sensor reading. We can always decorate it later. Temporarily we will give it an outset border. Most important at the moment is to get all the elements of the application working properly. To represent the content level of the red color under the sensor, another Visinode is created inside the display frame and painted red. The new red Visinode needs to be linked to the sensor. To do this, the element is dragged and dropped into the code window, where it may be identified as a variable named o_clonable. From here on, the sensor element can modify our new red Visinode to the extent we permit. We do, however, need to add some JavaScript code to affect the Visinode dropped into the code window. The o_clonable is a so-called JavaScript DOM. It possesses the properties and attributes laid out by HTML and JavaScript rules. There is no need to know how it works, but rather, what it does. In this particular case, we intend to allow the color sensor to manipulate the height of our new red Visinode. Here, the o_clonable height is set to be the value of the red readout. The red variable comes as a numeric value, but the HTML web page requires a string. Therefore, the variable must be stringified to be understood by the web page. So numeric variable gets the toString suffix. The red variable in the vprint line has the suffix toFixed. Essentially, toString and toFixed are the same, except toFixed forces the variable to be displayed as an integer. It is good to be aware of the difference between number values and strings. Math cannot be applied to strings. The height of the new Visinode should change as the sensor registers the color within itself. We may have to extend the height of the display panel to accommodate the full strength of the sensed color. For the next step, we will attempt to activate the rest of the colors. To create a bar element for each color, the red bar is simply cloned to the right and painted accordingly. Then each bar is linked to the sensor element, the same way the red bar was previously incorporated. The o_clonable objects must be distinguishable, otherwise there will be disaster. We assign the first letter of each color to each element, and then we copy and paste the JavaScript line we wrote for the red color 2 times. The word red is replaced everywhere with the words green and blue, same goes for the letter R. We set the sampling interval to 100 milliseconds or 10 samples per second, and then, we will do some testing. This video is produced using a 4-year-old computer. It is slow. To speed things up, it is better to record at lower resolution, and focus on visifront only. Therefore, it is better to move from a portrait view to a landscape view, and then run the video recording. Right-click on the calibration video to bring up the context menu. The video can be looped, and if it is asynchronous, the speed may be increased to test the technical limits of the available system. A fairly simple Visinode has been added to our project. It contains a function called wdLevelMonitored. With respect to the top left corner, this function compares its own position within its parent Visinode to a value passed to it. If the value falls outside its perimeter, the function returns the string content, high or low. If it falls within its perimeter, the function returns box. Just after the color contents are computed inside the sensor function, we will call the wdLevelMonitor function to process the value. If all is done correctly, the level monitor should tell us if the red intensity falls outside high, low, or inside its perimeter, the box. The level monitor doesn't care about the horizontal position of itself. The only thing that matters here is the vertical level. Nothing should be printed unless the color content value is inside the wdLevelMonitor box. Once the level monitor and the color sensor are interacting correctly, we will clone the red level monitor twice and paint each border to match the color of their respective bar. Every new level monitor cloned needs to be individualized. This can simply be done by adding a single letter to represent its color. We will now have to allow the color sensor to call every new wdLevelMonitor individually and use the correct color labels for each. Here, we take a significant step towards our end goal. The conditions are set so that each color level must be inside its respective wdLevelMonitor box for the watchdog to log a security breach.
Oops, forgot to color the borders of the level monitors.
The vprint function is provided by visifront, but the application will have to stand alone and operate independent of visifront. Therefore, an extra log box needs to be added to our project somewhere within the workspace.
Another blunder. Only the red WD level monitor is called. That must be rectified.
The spinning, color calibration, is just a video like any other video. We have seen how it works. So let's cut the story short and bring in a different video. Since the erase command erases the Visinode including all its children, we need to rescue our enhanced color sensor, so we don't delete it along with the calibration video. In other words, it needs to be pulled out of the video frame before the frame is deleted. Then we can drag another movie into visifront and see if we can extract any sense from it. We should adjust the color sensor to capture the area of interest exclusively. For serious applications, there are many technical limitations to consider. These issues are often computable, and when not, one may apply the trial and error method like we do here, towards an acceptable solution. Here is a bigger and better recording. Next, the video will be replaced by the USB camera attached to this computer. Same cautions are necessary to ensure the enhanced color sensor is not erased, although it is already saved on the stack and retrievable. The real world is getting ever more complex. A person may spend a lifetime on just a small portion of what is required to bring projects to fruition. We hope the visual attributes of Visinode will make individuals more effective and help entrepreneurs and communities bring projects to perhaps an equitable level prior to a major financial commitment.
Okay, we finally got back to our watchdog project, a web application. Let's open the window a little bit so we can see what we're doing. Right? And we start by clearing the log. The log can actually slow the computer down. And right now we are running at 4 samples per second. This computer is connected to a web camera through the USB port. It's a desktop computer, and we only have the orientation, the landscape orientation available to us. But this application has been written for, designed for mobile phones, smartphones, or a handheld device of some sort. So we need this, therefore, this portrait orientation, and that is what this container is. And to this end, we have added some buttons. These buttons allow the user to manipulate these elements up here and this eye over here without using a mouse. And we want to do just that. If all of the color bars are inside their respective color boxes, the alarm is going to be set off, conditionally though. And let's do just that. Let's turn the alarm on so we can hear what's happening. All right, and we need to move the green down a little bit. So let's do that. Green down a little bit. No, this is red, sorry, green. Down, perhaps it's a bit narrow. The bars are a bit unstable, so let's make it a little bit more tolerant. And here we move the blue level monitor. We also increase its size, and let's move its top down. And there goes the dog. There goes the dog. If one of the color bar gets outside the color box or its respective color box, that is going to enable the alarm. And when all the bars are back in their boxes, the dog is going to bark. It seems that the red may have peeked out of its box. I'm going to try and move a little bit, and there we go, and back in. Okay, I'm going to silence the beast and publish. We downloaded this application. It is now available in your downloads folder, and we're going to publish this as well. We're going to add the QR code. Drag this QR code into our application. Adjust the size a little bit. Anyone aiming, it's QR scanner at this element will be directed to this application. You can use it as you wish, free of charge, with one condition, and this condition is that there is a reference whenever you publish this application somewhere, but there is a reference to Visinode.net. And let's publish this page. It is now available at https://visi.net/visi_ct.html. The page is now at your discretion, and good luck.